region between two curves. Focus up here, boys and girls. So we've been finding area bounded by a region, or by a graph, a function rather, and the x-axis, right? So now we're going to look at an area that's bounded between two curves. So I want you to draw these two curves. We'll draw this one, and we'll make this one F. And then we'll draw this one, and we'll make this one G. So the area bounded between F and G, you can see, well, let's look at it this way. The area bounded between F and the x-axis is this area here, right? The area bounded between G and F and the x-axis is this part here, right? So this is what I want in here. So how do you think I could figure out what that amount is? If I find the area bounded between F and find both and do what with them? Subtract them, because I want that gone, right? So if this, it says between A and B. This would be like A, and this would be B. This right here is the actual area that's bounded between both of them. I probably didn't do it. My shading job is crap. Sorry. I was trying to make a point and it didn't come out right. Didn't come out well anyway. So that's the area between the two, right? But I have this area right here that I need to subtract out. And that's the area between G and the x-axis. Does that make sense to you? So what I want to find is, I'm going to find the integral from A to B of f of x dx. And I'm going to subtract the integral from A to B of g of x dx. Make sense? So we've been adding and subtracting them when we're looking at rate in and rate out. We're doing it visually now. Okay, and then we're going to kind of go back and put it all together. But so this is the same thing as the integral from A to B of f of x minus g of x dx. So when we were doing rate in, rate out, and I know it's been a few days now, we were writing everything as like initial plus the rate in, plus the integral of the rate in minus the integral of the rate out, right? There was a reason that we didn't write it like this altogether, even though we could have on some of them. Because remember that one problem where one of them, the rate in was going from like 0 to 4 and the rate out was going from like 2 to 4? So if you don't always split them, sometimes you miss that. And but here it doesn't really matter. We can put it all in one because it's A to B and it's like one big picture. Does that make sense? So what this is also, another way to look at this is the integral from A to B of the top minus the bottom. That's the order in which it goes. And we're doing this visually so we would know which one is the top and which one is the bottom. Okay? Everybody okay with that? So to find the area bounded between two functions, when you have y equals a function of x, this is what we get. If we have x equals a function of y, so if our picture instead looked like this, make this f, and make this g, right? And I won't do all the weird shading this time. I want the area that's bounded between them. This kind of so this is x is a function of y, which means we're integrating and finding the area between the functions in the y-axis. So this being our boundaries, least to greatest, this is A, this is B. A would be the least, because it's always least to greatest. I know I usually want to put A up here too, but I have to remind myself when I'm on the y-axis. So we're finding it this way, right? The area between F and the y-axis and the area between G and the y-axis, and then we subtract that G area out, okay? So this would look like this. The integral from A to B of F of y dy minus the integral from a to b of g of y dy, which again we could write it together because the a's and b's are the same. That's the integral from a to b of f of y minus g of y dy, which is the integral from a to b of the right minus the left. dy. Okay, so it's top minus bottom or right minus left. Okay. Everybody good so far? All right, so let's actually draw some and do this. So we're going to find the area bounded by the following graphs. Okay, so not between the graph and the x-axis, but between the two graphs themselves. We're supposed to draw the figure and shade the bounded region. All right, so this y equals 3 minus x squared. What is that going to look like? Parabola, and tell me about the parabola. It's opening down, and is it at 0, 0? It's a 0, 3, 1 up 3. So we're here at 1, 2, 3, right? So I know it looks something like this, right? And then this y equals negative x plus 1. Well, I'm going to go up to 1. Am I going like that way? I'm going this way. That's what I was trying to get at. So it looks something like that, right? And the first time I did this, I made my little hash marks. I was finding the exact points, and my graph looked like trash. So this was a much better graph. And then we're going to go figure out where this is. So this is my A, and this right here, this would be my B. Right? So I need to figure out what those x values are. So this is just a system of equations, right? Where you look at where do the graphs intersect. Remember we're doing that back in Algebra 1? If you had two lines that intersected right here, that was a system of equations, and you go do that, right? So you can solve a system by graphing, you can solve it by substitution, you can solve it by elimination. Given these two equations, I think substitution would be the easiest, right? So they're both equal to y, so then I can set these two pieces equal to each other by substitution. So I know that I want to figure out when does 3 minus x squared equal negative x plus 1. Figure out where is that. So that's a quadratic, which means the first thing I do is set it equal to 0. I want my x squared to be positive, so I'm going to move all that over to the right. So this will give me, oh, no, it won't give me 3. It will give me 0. 0 equals x squared minus x minus 2. We agree with that? All right, so then I factor. Me too. A little puzzle. So I know it's 2 and 1. Which one's negative? The 2. Which means I get it's at x equals 2 and x equals negative 1. So this is at negative 1 and this is at 2. So those are my limits of integration because this is my shaded area. So now I'm going to go find that. We are going to find the integral from negative 1 to 2 of the top, f of x. So was that the first or the second one? The top is the first one because that's my parabola. So 3 minus x squared minus, I need parentheses because it's more than one term, negative x plus 1 dx. Everybody with me? Okay, so now I'm just going to simplify what's in those parentheses there. So this is equal to the integral from negative 1 to 2 of negative x squared plus x plus 2 dx. We good? Ask me a question if you got it. All right. So now, is this a pretty simple thing to integrate? Yes, so I'm going to add 1 to this exponent, so this gives me negative x cubed divided by 3 plus, add 1 to the 1, so I get x squared divided by 2 plus 2x. Do I need a c on this? No, because I'm doing the long thing. I'm going to evaluate it from -1 to 2. So c is just kind of in the way when I do that. Right. Ask me questions. What questions you got? We good? Okay. So now I'm going to substitute this in. I'm going to substitute in my 2. So I'm going to get -8 over 3. And now I know you're going to think what I'm about to do is weird, but just trust me on this. Plus 2 squared is 4. I'm going to put 4 over 2. And I'll tell you why in just a minute. You don't necessarily have to, but I'm going to. And it worked out well for me on a couple of these. But again, if you put 2, it's fine. But and then I put 2 in there, and so it's going to be plus 4, right? Minus, I'm going to open my parentheses. I substitute in my -1. -1 cubed is -1. The negative of that is a positive 1. 1/3. Plus -1 squared is 1 over 2. And then -1 in here gives me a -2. So look, by leaving this as 4 over 2, instead of making it 2, I can now easily combine it with this 1/2 without getting a common denominator. Does that make sense? And it's just kind of, sometimes it helps you with fractions along the way. I mean, the next step, if you didn't need it, you make it into 2 and you move on with your life, but you just kind of never know what's going to happen. So this is the way I'm going to simplify this. Let me come way over here. So I have this -8/3 minus 1/3. So I'm going to make that -9/3, which I know is -3, but I'm making it -9/3. Plus 4/2 minus 1/2 gives me 3/2 plus 6. Okay. Everybody with me so far? Not saying you have to do it my way. I'm just saying I was going to end up with fractions anyway, right? And what is my common denominator here? 6. So I can double this first one. This will give me -18 over 6 plus 9 over 6 plus 36 over 6. So this -18 plus 9 is a -9/6. So here, I'm just going to, you don't have to write this step, but I'm going to, or I'm going to forget what I just said. And sometimes it's better to just write out every single little step. Now, could we have stopped somewhere? This right here is a safe stop, okay? But we're continuing because we have to be able to find answers that would match multiple choice. We want to make sure that we don't freak out when we have fractions, okay? So then I really just need to do 36 minus 9. What's that? 27. So this gives me 27 over 6. Bless you. And then that reduces to 9/2. Okay? But this is your safe stop, and it's fine to stop there once you have substituted it in. But you need to be able to also have the ability to get to 9/2. Okay? How are we doing? Questions? Okay. So let's look at number B. All right, so I have x equals 5 minus y squared. Okay, so we could change this into, we could change this and solve for y, but if you have y squared instead of x squared, what has happened to your parabola? It's just sideways, right? And then this means that I just go to the right, 5, right? And it would look like this if it was a positive y. It's a negative y, so it's going to look like this. So we're going to be here at 5. That's 5. Not that it necessarily matters, but we have something that looks like this. Okay. Now, because the next one's a line, I think solving for y might actually be helpful. So this would just be y equals x plus 1, right? So I can go to 1. My slope looks like this. So my function looks something like that. You with me on that? That's my shaded part. Oh, see, I want to make this A. Is this A? No, that is B. And then this would be A right here. And it's on the, we're finding the areas bounded by the y-axis. Okay? Which means I want my A and B to be y, so I need to figure out when these y's are the same. So I'm going to do 5 minus y squared equals y minus 1. Set it equal to 0. 0 equals y squared plus y minus 6. Factor. I know that it's 3 and 2, and my 3 would be positive in the factors. So I get y equals negative 3 and y equals 2. So this is negative 3 and this is 2. Ask me a question if you have a question about where anything came from. Okay. All right. So now, because this is a y and we're laying down and everything is going with the y-axis, when I integrate, I know my limits of integration. We're going from negative 3 to 2. I don't have a top and a bottom. Is it right minus left or left minus right? Right minus left. So the right is the parabola-looking one. So this is 5 minus y squared minus the left, which is parentheses y minus 1 dy. Okay, we're good? So I'm going to clean up the inside. This is the integral from negative 3 to 2 of negative y squared minus y plus 6 dy. Are those parentheses I put in that step important? Yeah, they are, right? Because if not, then the dy just goes on the 6. All right, you go ahead and integrate that. Let me give you a second to integrate it. How do you integrate? What are you going to do first? Yeah, you're going from here to here. There you go. Good. What are you going to do first? Add 1 to the exponent to make it y cubed. Then you divide by your new exponent. That's how I got from, well, you skipped a step, but yeah. So I got negative y cubed over 3 minus y squared over 2 plus 6x. Do we agree with that? Yeah? We agree with that. Okay, good. All right, so go ahead and substitute in your numbers. I'm going to let you do that. Give you a second. Struggle through your fractions a little bit. Watch your signs so you don't confuse yourself about things. Substitute in, find it, and then keep going. Don't wait for me. the left side of the thing. You're going to have to be more specific. That's okay. Like, me substituting in 2. That, yeah, so this is where I substituted in 2. This is where I substituted in -3. So, because you evaluated at the top minus evaluated at the bottom. Okay, we good on that? And remember, again, this is your safe stop, yes, but we need to be able to manipulate. And again, I could have made this into just 9, and I could have combined it differently. I just kind of chose to leave it and see what was going to happen. And go from there. Because what would have happened is I would have ended up with some other, I don't know. I would have had different numbers than this, and they may not have been as easy to work with. I don't know, because I didn't do it that way. But did we get 125/6? What questions do we have? Nothing. We're good. Okay. All right. So we're going to sketch and find the area of the region bounded by f of x equals sine x and g of x equals cosine x. Okay, and we're going between pi fourths and 5 pi fourths. So the left side of the graph doesn't even matter, right? So let's just think before we start, from 0 to 2 pi, that's what sine looks like. And from 0 to 2 pi, that's what cosine looks like, right? And if I'm going to 5 pi fourths, I am going to more than pi, right? So I need to go to more than just half of it. So I'm going to go ahead and go from 0 to 2 pi. So that means my sine function. Oh my goodness. It's okay. I just laugh so I don't cry. Okay, there we go. Okay. Oh, I finally have a pen to work, and the graph looks like trash. Okay, so that's kind of what sine looks like, right? Cosine, then, we start here, and it goes something like that. Okay, so I was just going from 0 to 2 pi, didn't worry about the left-hand side at all, since it's telling me. So here I don't have to figure out my limits of integration, I know what they are, but then I got to figure out what's going on my graph. I know that this is 0, this is 2 pi, so this is pi, right? So here and here, this is pi halves. So pi fourths is right there. That's this point here. That's that point. Yes, and then this is pi, so that's like 4 pi fourths, which means this is 5 pi fourths. So this is what I have right there. That's what I'm looking for. Does that make sense to you? We good so far? Okay. It's from pi, yeah, so this is 0, this is pi fourths, this is 2 pi fourths, which is pi halves, this is 3 pi fourths, 4 pi fourths, 5 pi fourths, 6 pi fourths, so yeah, it's that point. It's just a little past pi. Okay. So you get this weird little paisley looking thing. Are we good on that? Sketching. Okay, so we're going to integrate from pi fourths to 5 pi fourths, and we're going to do top minus bottom. So the top one is which one? The sine, purple sine. Yeah. All right, so it's sine of x minus cosine x dx. Because it's top minus bottom. We do top minus bottom and right minus left. Okay. That's why you have to kind of actually see it. Like you actually need a sketch to be able to figure out which one goes on top. Yeah. Yeah. Say what? Not necessarily. Yeah, I know. Yeah, so it's not always f of x minus g of x. It could be the other way around. You've got to be careful with that. All right, so let's integrate this. Remember this, sine, cosine, negative cosine, right? So if I'm going to integrate sine, what does that become? Negative cosine. So this is negative cosine of x. And then when I integrate cosine, I get sine, so it's minus sine of x. evaluated from 5 pi fourths to 5 pi fourths. Okay. So the first thing I'm going to do is just substitute it in. Okay. So I'm going to get negative cosine of 5 pi fourths minus sine of 5 pi fourths minus parentheses negative cosine of pi fourths minus sine of pi fourths. Okay. Yeah, okay, because 5 pi fourths is in what quadrant? The third. And what's positive in the third quadrant? Well, okay, so 5 pi fourths is in the third quadrant. Sine and cosine are both negative in the third quadrant. All right, so that's all we need to know as far as what our SIGNs are going to be on this. But what is this cosine of pi fourths? And what's the sine of pi fourths? Okay, so when I take the cosine of 5 pi fourths, that's negative square root of 2 over 2, but I have to make it negative, so I get square root of 2 over 2. Sine of 5 pi fourths is negative square root of 2 over 2, but I have to make it negative, so it's plus square root of 2 over 2. Minus, and then this is going to be negative square root of 2 over 2 minus square root of 2 over 2. Everybody good with where all that came from? Because you got to know your trig values, you got to know your unit circle. All right, what's the square root of 2 over 2 plus the square root of 2 over 2? Yeah, it's 2 square roots of 2 over 2, which is the square root of 2, right? I have half of one, I have another half, gives me a whole square root of 2. Minus, and then negative square root of 2 over 2 minus square root of 2 over 2 is going to be negative square root of 2. And then I add it, and I get 2 square roots of 2 in the end. So many 2's. Even though this one was not complicated, they didn't ask you for complicated trig values or anything, would it have been really easy to make an SIGN error somewhere? Yes, absolutely. Okay. All right, one question. I know. Any good? We all good? Okay, so we are going to use our calculator from the next one, which means we need to type these two things in quickly and efficiently and correctly. So sit up and start typing. So I'm going to add a new one. I'm going to add graphs. And then I'm also going to add calculator. All right, so 3x cubed minus x squared. Oops. F2 is going to be negative x squared. Oh, yeah. Squared plus 2x. Okay, so it should look like that. And on my paper, hang on, I'm going to write down that this was F1 and this was F2 so that I remember what to do depending on how I'm going to subtract them and I know which is which, right? Okay, so it looks like they intersect at 0 and 2, right? But we're going to make sure that they actually intersect at 0 and 2. And sometimes they won't be exact, so we need to know what to do to find it, okay? Yours does not look like that. Okay, your cubic is not right then. So tab, go up.
3x minus x squared.
So you have times 10x. Times a negative 10x. Okay, we got our graphs. We good? Okay, fixing it. We good? We good? Okay. So I want to know where they intersect, right? Here's how we're going to figure that out. We want to do something, we're going to find it in the menu. What do we want to do? Yes, we do, but not just yet. Right now we're just analyzing the graph. So we're going to do 6. And I want the intersection, which is 4. Okay, so now when you have this, and I can't, you use your little trackpad to move it. I can't do that up here, so I'm going to, Sorry. So I'm going to move this. Okay. There you go. I'm going to move it this way. So that means I need to be to the left because there's 2 intersections. I need to be left here, and then I'm going to click OK, and then I'm going to arrow to the right. Oh my gosh. And then it kind of highlights it, and it shows me where the intersection is. I can hit Enter, and my intersection is at 0, 0. Okay? It's a face. It is a face. Okay? We good on that? If it was not a pretty number, we'd want to store one of those numbers. Okay? So like if I was looking for the intersection and the intersection was like 0.7834, whatever, then I'd want to store that in A or store it in B. You don't need to right now because it's 0. Like, I mean, you can, but you don't need to. All right, so then we're going to do that again. Menu, analyze the graph, intersection. I'm going to move this, oh, it does let me, to the left side of this intersection here, hit Enter. Then move it to the right so it's on the other side of it, hit Enter, and it shows me the intersects at 2, 0. Which it totally looked like it, but again, you have to make sure, and it's not always going to be real pretty. Okay? So our intersections are at 0 and 2. Plus we have to draw it, right? So I'm going to draw this. Let's see. This first one. Oh, that's not good. That's kind of big. Yes, I do expect you to draw it. It does not have to be beautiful, but it has to be something. It should look something like that. And we are intersecting here. This is at 0. This is at 2. So if you're not sure, in this case, we should be able to tell that my pink one is a quadratic, so it's the g of x, right? But if you can't tell on your graph, you can see which one's F1 and F2. You can go back and look at it. So we're going to integrate from 0 to 2. Which one is the top one? G of x, yes. G of x minus f of x dx. Now, because I wrote this down, okay, this is something they're going to look for. I wrote this down. It's based on what they gave me. For myself, because I labeled them on there, I'm going to say what I'm really doing is I'm integrating, and it's f2 of x minus f1 of x dx. Okay, so that really only makes sense to me. I mean, the readers will see that, especially because I labeled it, but I want to make sure that I put it in the calculator correctly. So then we're going to go back over here. We go back to we go here. Now we do calculus, yes. Menu, what are we going to do? Calculus. We want to do a numerical integral. We are going from 0 to 2. And then here, remember to get F2, I can hit variable, F2 of x minus variable F1 of x dx. And then enter. Yeah, you will still, yeah. Because this is one we could have totally integrated by hand. The graph, we're saying, okay, you can use your calculator if you want. It's fine, but ugh. Most of the rest of the stuff is BC stuff. I think we may just have, I think it's just this unit. I'm going to have to look at it. And then we're going to kind of be reviewing and going back over lots of things. Homework. Practice. Practice, practice. No, so you're just going to have to put your little X and Y axis on there. I mean, just a little T-chart, but. Which might have been better on that trig one, because then I wouldn't have had the left-hand side. I'd have a better graph, but put them there just so that your graphs could look a little bit better.